Alright, I get it. You want to learn wall running. Well, you're in luck today because in this video, I'm going to be showing you how to add wall running to your first person or third person character controller in Godot. Okay, so we've got Godot up and running, but the first thing that I want you to do is open up your web browser and go to github.com/garbageYT/Godot wall running. This will take you to my GitHub repository for this tutorial, and in it you'll see two files. You'll see wallrunstarter.gd and wallrunstarter.tscn. Go ahead and download these two files and load them into your Godot project. I assume you already know how to do this, but if you don't, let me know in the comments and I'll be happy to help you out. Once you got everything imported and set up, you should now have a scene called wallrun. And if you look into the script, you'll see that it comes with code that I've pre-written as a starter for this project. This tutorial will build off of this starter code, and so if you want to follow along with this tutorial exactly as I have it here, make sure you do everything that I just told you to do. The first thing we're going to do is we're going to go into Project and Project Settings. Under the General tab on the left, scroll down until you see Physics, click on Common, and set Physics FPS to 240. By default, this is set to 60, and you don't actually have to do this if you really don't want to, but I prefer to set things to 240, and if you want to follow along with this tutorial exactly as I have it, I suggest you set it to 240 as well, otherwise your character's physics might act differently than mine. The next thing we're going to do is we're going to go into Input Map, and we're just going to make sure that we have a couple of key bindings. We need to make sure we have a move forward binding as well as a jump binding. If you've been following my other tutorials, you more than likely already have these set up, but if you don't and you don't know how to set one up, leave a comment down below and I'll be happy to help you out. So in order to give our character the ability to wall run, we're going to create a new function. Under this block of code here, we're going to write func wall run open close parentheses. So the first question we need to ask is, how do we want our character to enable wall running? Every game does it a little bit differently, but for this tutorial we're going to make it so that in order to wall run, you have to hold down the jump key while you're on a wall in order for your character to run on the wall. And so we need to establish a few conditions. If input.isActionPressJump, so the first condition is that you have to hold down the jump key, but now we need to add another condition because we want our character to be able to jump normally if they're just standing next to a wall without moving. And so we'll say that our character will only wall run if they're moving in a certain direction. And so we'll write if input.isActionPressedMoveForward, so if you're holding down the jump key and you're holding down the move forward key at the same time, the next condition is that our character has to actually be touching a wall in order to wall run. And so we'll write if isOnWall, so if we're holding down the jump key and we're holding down the move forward key and our character is on the wall, we'll say fall.y equals 0. For this particular character controller, our gravity is controlled by this code right here, and fall is the vector that we use to control gravity. And so by saying fall.y equals 0, we're effectively saying turn off gravity. And so with all of this written down, we should have ourselves a fairly basic wall running system in place. It's got some flaws and we'll get around to fixing them very soon, but at this point we just need to tell the game to run this function. And so down in physics process, under this block of code right here, we're going to write wall run open close parentheses. This is what is referred to as calling a function, and basically all we're just saying is saying, okay, this wall run function that we wrote up here, run it. But before running the game, we're going to temporarily turn our first person character here into a third person character just to make things easier to visualize. And that's pretty simple to do. Click on the camera node and move it back a little bit. Now instead of seeing things in first person perspective, we're now seeing things in third person perspective. It's really that simple. So now when you run the game, if you go up to a wall and you jump and you hold down the jump key, then your character will stick to the wall. And this is basic wall running. However, there are a couple issues with the way it works right now. First of all, if you run on the wall, you'll notice that if you don't get the angle just right, you'll fall off the wall. And that's because if you don't get the angle just right, then the character will break contact with the wall and then the wall running will no longer work. You'll also notice that if you get right up next to a wall and you try to wall run, you'll end up wall running very low to the ground. So let's fix these issues. To fix the reliability issue, we're going to take advantage of the power of normals. So what the heck are normals? So at least in 3D graphics, every 3D object is made up of faces. So for example, this cube right here is made up of faces, and each individual face is facing in a certain direction. And so for example, this top face on the cube is pointing upwards. This face is facing this way. This one is facing this way. And the direction that these faces are pointed towards, that's called the normal. So let's say that this is our wall, and this is our character bumped up right against the wall. In Godot, when two objects collide with each other, you can get some information about that collision. So if our character bumps up against this wall, we can actually get the normal information about the wall when we bump into it. And so if we bump into the front face of the wall here, then we can get the normal of that face. In this case, it's going to be an arrow pointing this way. And this kind of information is actually really useful because in order to fix our reliability issue, what we're going to do is while our character is running on a wall, we're going to be applying an additional force to the character that pushes it up against the wall so that it always maintains contact with the wall so that the character fulfills all of the conditions necessary to keep it while running. And so a very simple way to do something like this is to just get the normal of the wall whenever we make a collision and apply a force that is equal to the opposite of that normal. That way, it doesn't matter if our character is here, or if it's here, or if it's here. The direction of the force pushing the character up against the wall will always be in the direction that is opposite of the wall normal. If you didn't do this, then you would have to write a separate chunk of code for every possible collision point on your character's model, which is just completely unrealistic. To do this, we're going to go back to the script, and at the top, where all the variables are, we're going to write var wall normal. Wall normal is going to represent our normal that we get whenever our character bumps into a wall. For the moment, we're just going to leave it blank. Next, we're going to go back down to our wall running script, and under this line, we're going to write wall normal equals get slide collision 0. So what we're saying here is that if we're holding down the jump button, if we're moving forward, and if our character is on the wall, we're going to get all of that collision information and we're going to call it wall normal. Now get slide collision is a built-in function in Godot and it provides information about every single collision that happens. And since it's possible to have multiple collisions at a time, we're going to tell Godot to give us the information of the very first collision that happens. And so we're going to write 0. It's pretty common in programming to start counting at 0, and so 0 just represents the first collision. Then under this line, we're going to write direction equals minus wall normal dot normal times speed. Whenever we want to pull information from get slide collision, all we need to do is call it by its name. In this case, we called it wall normal. Now, get slide collision provides a lot of different types of information, but the only information that we're concerned with is the normal information. And so in order to pull the normal information from get slide collision, all we need to do is write wall normal and the information that we want to get. In this case, it's dot normal. The variable direction is the direction that we want our character to move. For example, in our movement script, when we press the move forward button, we set the character's direction to the direction that it happens to be facing. And then once we have direction, we can then tell the character to move in that direction. So if we go back up to our wall running script, all we need to do in order to apply a force to our character that presses it up against the wall is to set the direction equal to the opposite of the wall normal. And then we multiply that by speed just to make the force a little bit stronger. So now when you run the game, it won't be very obvious just by watching the video, but if you try to wall run, you'll notice that it's a lot more reliable. In fact, it's too strong almost. But now we run into our second issue. If our character is already up against the wall and you try to initiate the wall run, it'll wall run, but it'll just happen really close to the floor because the wall running script has pretty much kicked in instantaneously, and so there hasn't been any time for the character to jump up. To fix this, we're going to go back into our script, and under this line, we're going to write yield get tree dot create timer 0.2, comma, timeout. And so what we're doing is we're creating a yield, basically we're waiting, and what we're waiting for is get tree dot create timer. We've created a timer, and we've set that timer to 0.2 seconds, and you can adjust this to whatever you want. And we want to wait for that timer to time out before we move on to the next bit of code. And so what this does is if you are already up next to a wall and you try to wall run, the game will wait 0.2 seconds before initiating the wall run script. That way your character has a little bit of time to jump up in the air before sticking onto the wall. So now when you run the game and you're up against the wall, when you initiate a wall run, your character will jump up in the air a little bit before sticking to the wall, just like we said it would happen. And at this point, we're pretty much done with wall running. But right now, our character can pretty much wall run indefinitely. And if we want to make it so that the character can only wall run for a certain amount of time, then we need to make some changes. To do this, we're going to go back to our character scene. We're going to right-click on wall run, and we're going to add a child node. And we're going to add a timer node. Click on timer, and on the right in the properties, set the wait time to how long you want your character to be able to run on walls. In this case, I'm just going to give it 2.5 seconds, and we're going to enable one shot. Then we're going to click on the node tab. We're going to right click on timeout, and we're going to click connect. Click on wall run and press connect. This adds a new function to the bottom of your script called onTimerTimeout, and basically this is a function that will run the moment that your timer runs out of time. Next, we're going to go back to the top of our script to our variables, and we're going to write var wRunnable equals false. And this just stands for wall runnable, and this is basically saying, is our character able to run on a wall or not? So now we're going to go back down to our wall run script, and under this line, we're going to write if wRunnable. So if wRunnable is true, then we're going to highlight all of this code, right click, and select indent right to bump all of the code over to the right. Then we're going to go down to our physics process function to our jumping script, and under this line, we're going to write else wRunnable equals false. So if our character is not on the floor, then gravity will be enabled. If they are on the floor, then they're not able to run on walls. Then under this line, we're going to write wRunnable equals true, timer.start. Also right now we're getting an error that says identifier timer isn't declared in the current scope, and that's because we haven't yet created a reference to our timer. So go back up to our variables, and under this line, we're going to write onReadyVar timer equals $timer. So going back down to the code we just wrote, the moment we press the jump button, and if our character is on the floor, then our character will jump, and our character will be able to run on walls, and we will also start counting down on that timer that we created. Then we're going to go all the way down to the bottom to our onTimerTimeout function. We're going to delete this, and we're going to write wRunnable equals false. So when the timer runs out, our character will no longer be able to run on walls. So if we go back up to our wall run function, the reason why we put if wRunnable on top is because we want to make it so that our character can only run on walls if wRunnable is true. If this isn't true, then our character won't be able to run on walls. So our character gains the ability to run on walls the moment they press jump, and a timer will start, and once that timer ends, then they'll no longer be able to run on walls. So now when you run the game, if you run on a wall, your character will run, but only for 2.5 seconds before it falls. And that's pretty much it for wall running. If we want to turn this back into a first-person character, it's pretty simple. Just go back to your character scene, click on the camera node, and in the properties on the right, under transform, just set the translation of the z-axis back to 0. Now when you run the game, you're back in first-person mode, but you can still run on walls. I mean, there's a lot of things that you could add to this to make this look better and feel better, but this was one of the more difficult game mechanics for me to figure out. And there are probably better ways to do wall running than the way that I just showed you in this video, but at least we have something that works. Now, if you know of a better or simpler way to do this, then please feel free to let me know in the comments. Just like you, I'm learning this game engine as I go. I mean, I'm always open to learning more ways to expand my knowledge in this game engine. Anyways, I hope that you found this video useful. Don't forget to join our Discord server where we talk about game development, as well as a number of other Discord exclusive things, so stop by and have a chat if that's something that interests you. Anyways, thank you for watching. If you liked the video, make sure to like it, subscribe it, share it, bell it, and comment it. Thank you. Have a nice day.